The production supervisor on duty walked into our maintenance shop. He had a problem. The bread product he was running had dough weights that were varying wildly from piece to piece. When he measured the dough temperatures coming off the mixers, he found readings all over the place. Something was wrong at a system level, and he needed us to find it. I want to tell you what we found, but before I do, I need to explain what the system was, because this story is about a piece of equipment most operators use every day without ever having it explained to them. Commercial bakeries use two forms of refrigeration: gas refrigerant systems for freezers, kept isolated for food safety reasons, and glycol systems for cooling stainless steel surfaces where product contact is possible. Propylene glycol is used specifically because it is food safe. In this bakery, the glycol was mixed 50-50 with water, dyed lime green for visual identification, and stored in a holding tank. A rotary pump circulated the mixture. A submerged evaporator cooled it to 40 degrees. The chilled glycol traveled to the mixing room, where it ran through the jacketed walls of the mixer bowls. Why does this matter? Because when you mix 2,000 pounds of dough, the mixing action generates significant heat. Dough temperatures can rise to 100 degrees, and heat activates yeast prematurely before the dough reaches the divider. If yeast starts producing gas during mixing, the dough rises unevenly. Cutting it into pieces produces inconsistent weights, which is exactly what the supervisor came to my shop about. We walked over to the glycol system. The first thing I noticed was the temperature gauge, 55 degrees. It should have been at 40. My co-workers checked the chilled water system feeding the mixing room, also at 55. Both systems were 15 degrees warmer than they should have been. That 15-degree difference was enough to warm the mixer bowl jackets, which raised the dough temperature during mixing, which activated the yeast prematurely, which produced the varying weights the supervisor had measured. The whole production quality problem traced back to one system operating 15 degrees warm. Now we had to find out why. We started at the beginning of the refrigeration side of the system. Compressor operating, evaporator coil cool to the touch, no ice formation, expansion valve responding, condenser coil clean and functioning, receiver tank showing normal pressure. Every component in the refrigeration loop checked out. We ran through the sequence a second time to make sure we had not missed anything. Same result, nothing wrong with the refrigeration system, but the glycol was still 15 degrees warm. Something else was going on. On the third pass, I looked at the glycol holding tank itself. The level was low, below where it should have been. But when we walked round the tank, there was no puddle, no leak visible on the outside of the tank, no moisture on the fittings. Whatever was happening to the glycol was happening somewhere else in the system. I called the production supervisor over to explain what we had found. He immediately walked back toward the mixing area. The supervisor came back within a few minutes. He had found it. Behind the 6 mixing bowls in the mixing area, there was a puddle of lime green glycol on the floor. Next to the puddle was a ball valve. The handle was in the closed position, but at the open end of the valve, a single drop of glycol was still hanging. The valve had been open at some point, long enough for enough glycol to drain out to lower the tank level below its cooling threshold. Then someone had closed the valve, but the report of the accidental opening never made it to maintenance or supervision. And by the time we were called in, the temperature had risen, the yeast had activated, and the dough weights were varying wildly on the production line. I refilled the glycol tank to its recommended level. We purged the air that had been introduced into the lines when the valve was open. Then one of my co-workers removed the handle from the ball valve entirely. That was the permanent fix. Not a warning label, not a discussion with the operators, a physical modification that made accidental operation impossible. Production was running again within 30 minutes of the discovery. The dough temperatures normalized. The weights came back within specification. But then my other coworker returned from a phone call with our boss with instructions on what to check in the system. The same things we had already checked. 30 minutes on the phone. Advice arriving after the work was done. A direct call to the mixing room office would have delivered the same guidance in real time. It did not. Every video on this channel is a real story from 40 years in commercial bakery maintenance. This one is about how small, unreported events become large production problems. A ball valve was opened, it was closed, the event was never reported. 15 degrees of temperature drift became inconsistent dough weights on a full production line because a 5-minute conversation between an operator and a supervisor never happened. A reporting culture is not a soft skill, it is maintenance infrastructure. If your operational environment makes people afraid to report mistakes, the mistakes will find their way into your production quality numbers eventually. Subscribe for new content every week. Free field reference covering 25 equipment failure points, link in the description. Your maintenance team can use it directly.